All right, statistics students, I just want to bring your attention to exercise 22-10 because in this exercise you need to use raw data to do some inference. So here we're going to consider the activity where we looked at body temperatures for 130 healthy adults. And we want to analyze whether sample data provide strong evidence that men and women differ with regard to population mean body temperature. So here is the file. If you click on that, you can go ahead and download it. It's an Excel file, and then we'll upload it into our Guru in a minute. So first of all, what we want to do is look at the parameters. So the parameters are going to be mu, and that will be the the population mean body temperature for men and for women. So that'll be this one. We're going to use the symbol mu, and it's the population mean, not age, sorry. Population mean body temperature for men and women. Okay, so that's that. And now we're going to write null and alternative hypotheses for the significance test. Here, just make sure when you type it in, you're going to type the word equal to instead of the equal symbol. Otherwise, it's going to mark it wrong, right? So the null hypothesis is that mu women is equal to, so let me go ahead and type that in, equal to mu men. And the alternative hypothesis, I'm not sure yet which direction, so I'll just say not equal to. Mu women not equal to mu men. Okay, and now here is the third piece that requires us to use our Guru. So we're going to calculate the test statistic and the p-value, make a test decision at the 1,000th 0.001 significance level. So here we go. I'm going to go into our Guru, which I already logged in, and I'm going to import the data set that I just downloaded there. So I think it's in my downloads, body temps. There it is. Let's go ahead and open that up and hit upload. So now our Guru has that data. I'm going to go down to analytics, analysis, and mean inference 1 and 2 population. Now from here, I'll select my data set, which was body temps. And I'm going to choose, no, I'm not going to choose it. It doesn't have 2 variables. I have to click on the second option that says variable and by factor. The reason is because if I look at my data, my raw data, it's all kind of, you've got the body temp and the gender. So body temperature and gender. So I guess actually it also has body temp female and body temp male listed there. So there's 2 ways that you can do that. First way is if you click for variable 1, body temp female, and for variable 2, body temp male, then it'll propagate all your other information. So that's using those 2 columns in the raw data. Also, you could click on just variable, and if you chose the first one, which is just body temp, and then you could do by factor, and the factor would be gender, right? And then down here, you'd have to pick those 2 levels, female and male. Okay, now let me just go back and make sure I have the right thing for population 1 and population 2. So we're going to do mu women first and then mu men second. So women is population 1. You'll see it right here. It's like we're calculating mu women minus mu men. So just make sure we'll put that one in first. Females go first, men go second. Okay, and now if I go over here to population 1 minus 2, we'll do a test of hypothesis. And our significance level, again, alpha was 0.001 for this. And again, we don't necessarily have to put that in. And our alternative hypothesis is that mu1 minus mu2 is not equal to 0. Like always, we're going to use the t-statistic method. Let's go ahead and look at our results. All right. So I'm going to need the test statistic and the p-value first, okay? So let's go down here. My test, that's the observed T-stat, is negative 2.28543. I think I have to round that to 2 places, so negative 2.29. And my p-value is 0.0239383. Let me see how many places do I need. Both of them to 2 places. So I'm going to write 0.02. Okay, so again, looking at what we've got here, 0.02 is not less than 0.001. So the null hypothesis, unfortunately, is not rejected at the alpha equals 0.001 significance level because the p-value is not less than the significance level. Is not. That's at 0.02 is not less than 0.001. So there is not sufficient evidence that the average body temperature is different for men and women. It is not at that significance level. Okay, now same significance level corresponds to 99.9 confidence interval. So let's do that confidence interval. Let's go ahead over back into our guru and click on basics. And we'll go to the confidence interval, and we're calculating a 99.9%, so 0.999%, or 0.999 confidence level, and make sure that we check the t-statistic method. Now let's see what we get. Okay, all the way at the bottom here, the lower bound is negative 0.716, upper confidence level is confidence bound is 0.137. So now let's go ahead and read how we're supposed to type this in. So we're going to round to 2 places, and we have to interpret what it means. With 99.9% confidence, we estimate that women are between blank degrees cooler and blank degrees warmer than men on average. Okay, so let's go back to our values. Okay, so we did women minus men. So that means when the women's temperature was less or cooler, we get this negative value, because smaller number minus larger number. So that would be if I round to 2, it said 2 places, right? Round to 2 decimal places. Okay, so that'll be around 0.72 degrees cooler. Let's go ahead and type that in. Degrees cooler and blank degrees warmer. So that would be 0.14 degrees warmer than men on average. Okay, the confidence interval supports the conclusion of the test hypothesis because the value of 0 difference in average temperature associated with the null hypothesis is in that confidence interval. So remember, when we have that, again, looking at that confidence interval from negative 0.7 up to positive 0.14, 0 is in between there. So if you have a negative, one endpoint is negative, the other endpoint is positive, then 0 lies in between there. And when 0 is when the 0 difference in average temperature associated with the null hypothesis is in the confidence interval, then the null hypothesis is not rejected at that significance level. Okay? All right, so those things kind of coincide. When we fail to reject the null hypothesis, then 0 is in the confidence interval. All right, let's go ahead and check those technical conditions. We need to make sure that that it was a random sample of healthy adults, and that we have more than 30 in each population. So we got 130 healthy adults, and they're worth more than 30 in more than 30 women and more than 30 men. Does not say that these healthy adults were randomly selected. So I don't think these technical conditions are not satisfied. So if we go over here, the samples are not described as randomly selected. The sample sizes are large enough, though. But overall, those technical conditions are not satisfied. So we can't actually use the results to like make inferences about the population. Okay, so I hope that helps. That was a walkthrough of this first homework assignment. You might have slightly different numbers for those confidence intervals and such. But that's how we use our guru when we're working with the raw data.